Hey, Dr. Estrell in the chemistry lab again. We are doing the titration lab, and in the titration lab, we're using a burette, which you can see here. I'm going to have to try to set this phone down because I have to show you how to fill that burette, and then we're actually using vinegar. So let's see, let me switch this. A couple things that you're going to need to know. Known values. The vinegar that we're using, Tuscan Garden, is, as you can see there, 5% acidity. That means that this vinegar has 5% acetic acid. So that's a known value. We'll say 5.0 acetic acid. Sorry, light reflection. Hard to read that. The other thing that we have is that's a known is the concentration of NaOH. So 0.100 molar NaOH. Okay, so those are two known values. Now I'm going to try to set up my phone so that I can record me. Sorry, I know I'm flipping this thing around. Trying to face it towards the sink. Where in the heck is the sink? There. Maybe I can put this in the ring stand. So I have the burette. The burette is a very accurate way to measure liquids. I need to fill this burette with our NaOH, our solution of NaOH. Remember, 0.100 molar is its concentration. So I pour some of this into a beaker. Set my burette down. Get the NaOH, pour some into a beaker. I need to contaminate this burette with a little bit of that NaOH. So I'm pouring a little in, twirling it around to rinse it, draining a little bit out of the tip, and then dumping it out. So what I've just done is I've rinsed the burette with the NaOH solution that I want to put in it so that any other contaminants were rinsed out for the most part, and only the NaOH is in there. So now I'm going to fill it about half full. Okay, so now I open, shake, close, and you can see the air bubble that it releases, and it fills this tip with the NaOH solution. Now I can fill this all the way up near the top, and just for simplicity, I am going to set this right on. I'm gonna put it right on 0. So the reading is gonna be 0.00. Okay, so I'm adding a drop, taking away a drop, getting it right on the 0 mark. So I don't know if you could see that up close or not. But reading the burette is something that you'll have to learn to do. Let's see if you can see the numbers. I'm not sure if you can read that or not. I can't see it in the phone, but I filled it right to 0. Okay, so now the burette is ready. I'm going to put it back in the burette stand. The other thing that I need is some vinegar. So I have some of the vinegar right from the big bottle in here, and I need to transfer it from here into this flask using this volumetric pipette. So this is a part where I don't know if you can see this well enough or not. So I'm rinsing out this flask. It can have some water contamination in it. See if I can push this back. So now I've got to get, I think I need to stand to make this taller so you can see it. Now I've got to get 2 milliliters from this bottle without spilling it. It's in that beaker so it can't fall over into here. So I'm basically transferring 2 milliliters of vinegar from here into here. But I'm very accurately measuring it with this volumetric pipette that measures 2.00 milliliters. Okay, so I use this bulb squeeze the bulb, put it on top, and I create a suction. By releasing my top hand, I put it down in the solution. It's sucking liquid up into the volumetric pipette. I get rid of the bulb, put my finger on it. I don't know if you can see that or not, but the liquid level is, there's a line. You can see the line right there. Right there, see it? And I have to drop the liquid down until it's right on that line. I think you can just barely see that. There, it's right on the line. So I've got the liquid level right on that line. So now I can set this down. I have 2.00 milliliters. By filling it to that line, it fills to 2 milliliters. Now I'm transferring it into this pipette and letting it drain. And these are TD pipettes, that's to deliver. They deliver 2.0 milliliters. And you'll notice when it's done dripping, it's going to leave a little bit of liquid behind. And that's okay, it's meant to do that. So that last little drop falls off. There's a little liquid left. I'm going to touch it on the side. I've just transferred 2.00 milliliters into this flask. I also need 20 milliliters of water. Hang on, I'm gonna run and get a graduate cylinder. I didn't have everything ready for the camera. Graduate cylinder, I need 20 milliliters of water. So this does not have to be terribly accurately measured. I am using deionized water, purified, yeah, almost right on 20. So I got 2 milliliters of vinegar, I got 20 milliliters of water. There's one last thing that I need to add into here, and that is, put that where you can see it, phenolphthalein. So phenolphthalein is our indicator. Phenolphthalein, it has a PHTH, so it's fun to say. You kind of get to spit phenolphthalein. I'm gonna add, procedure says 5 drops, but 2 to 3 drops works just fine. 1, 2, 3. 3 drops. When phenolphthalein is in acid, it's in acetic acid, it's colorless. It has no color. But then when I put it in a base, it turns pink. So that's what we're doing. I'm gonna set this up now and I'll turn the camera around. So now we're ready to go. We filled the burette with NaOH, sodium hydroxide. I can control it with this stopcock. I can turn a little bit and just get dripping. And we have our down in the flask, 2.00 milliliters of vinegar, 20 milliliters of water, 3 drops of phenolphthalein. I want a piece of paper to make this a little more obvious to you. I apologize for carrying you around all over the place with me. I didn't have everything ready to go. Okay, here we go. So now I've slipped a piece of paper under there so that we can see right when it turns pink. So now I'm going to turn this stopcock so that it's dripping. I know that it's not really going to do anything for a while. So remember our initial reading, we filled this all the way up to the top. It was at 0.00, right, to start with. Now it's dripping in here and we're simply trying to get to the end point. And I already know, because the students being in here over the last hour, it's not going to do anything for a while. So I'm draining it down kind of quickly, giving it a swirl. It's not going to do anything until I get down close to 30. I think the earliest one, I'm starting to see some pink. I don't know if you can see that. We're at 20 milliliters, 21, 22. When it gets close, I'm gonna have to start dripping it in, and this might take a while. 24. I think I'm gonna start slowing it down. so I don't go flying past it. So now I'm dripping it at kind of a fast rate. You can kind of see it turning pink in the middle, right? And I turned the stopcock just a little so that it's a little slower. Hopefully you can kind of see that pink color appearing in the middle, but whoop, right there, that's it. Yeah, so the whole solution turned pink. I caught it within a couple of drops. Hopefully you can see that obvious pink color, right? It was colorless. Colorless like this vinegar here, and now it's pink. So I have reached the end point. The end point is when I've added enough NaOH from the burette to neutralize all the acid in the vinegar down below, and then one more drop reacts with the phenolphthalein and turns it from colorless to pink. So it's actually a separate chemical reaction between the acetic acid and the NaOH that I'm adding from the burette, and then the phenolphthalein reacting with the NaOH. Okay, so now I have to get a reading here. I don't know how well you can see that. It's pretty dang close to, trying to focus in here, pretty dang close to 29. And you see the 29? Dang, it is almost right on the money, just a hair higher than 29. So I'm going to call it at 28.97. 28.97. So 28.97. Okay, so looking at the data, here's your data for trial 1. That's yours. Your final reading is 28.97. 28.97 milliliters. Remember, our initial reading was 0.00. We did change this top number. So this top number we used, for all of these top numbers, we used 2.00 milliliters. I filled the burette to 0.00 milliliters, and then it turned pink at 28.97 milliliters. So then I subtract the final reading minus the initial reading. Final minus initial comes out to 28.97 milliliters. The other trials that you will need are here. So there's an extra trial 1, trial 2, trial 3, trial 4. You can use those for the other trials, right? So you can pause the video, write those down. You want to write those in for trial 2, trial 3, and trial 4. So you can just use, I would just recommend use trial 2 as trial 2, trial 3 as trial 3, trial 4 as trial 4, right? So you're really not using trial 1 here. Okay? So then your calculations, you're going to select the closest 3 trials, these bottom numbers, select the 3 that are the closest, and average them, and then you're going to use that average to calculate molarity. Molarity, it shows you on the first page, is moles of acetic acid divided by volume of vinegar in liters, so it's moles per liter. And then you're going to do a mass percent calculation at the end, mass of acetic acid divided by mass of vinegar times 100. And your mass percent should come close to the known value, which I showed you up there on the board, is 5.00%. And we got that from the bottle, right, the front of the bottle. So you're going to do a comparison in question 7 of your percent acetic acid to the known, which is 5.0%. Remember, that is a accuracy comparison whenever you compare it to the known. And then precision, you're going to compare trial 1, 2, 3, and 4. That's precision. Right? The actual chemical reaction they show you was NaOH in the burette being added to acetic acid, and that becomes sodium acetate and water. Right? So the hydroxide OH minus picks off this hydrogen and becomes water. So it's just simply an acid-base reaction. We have a base with an acid becoming salt and water. Okay, so if you need any help with the calculations, just ask your professor in your lab and they will help you. Hopefully this video makes sense.